So when the instantaneous acceleration is 0, the particle is 8 meters away from its starting point. Hello and welcome to our YouTube channel. Today we are going to solve question number 2 on my classical physics test 1, a course I did in 2021 at the University of Liberia. So question number 2 says the position along the x-axis of a particle in meter is given by the function x of t equals 7 minus t plus 3t squared minus t cubed. A. Determine the particle speed at time t equals 0. And B. Where is the particle when the instantaneous acceleration is 0? Great. So we want to determine the particle speed at time t equals to 1.0 seconds, given that the position function of the particle is x of t equals 7 minus t plus 3t squared minus t cubed. Now, the change in position of a particle with respect to time is called the velocity of the particle. So you can say determine the particle speed at time t equals 0. So the first thing we have to do is to find the velocity of the particle at time t equals 0. And the magnitude of that result, meaning the absolute value of that result, will give us the particle speed at time t equals 0. So let's go. Find the derivative of x of t, that's x prime of t, equals the derivative of 7 with respect to t is 0. The derivative of negative t is negative 1, plus the derivative of 3t squared is 6t, minus the derivative of t cubed is 3t squared. Now this is the velocity of the particle. Now let's find the velocity at t equals to 1.0 seconds. So we know that v of t is minus 1 plus 6t minus 3t squared. So v of 1.0 will be minus 1 plus 6 times 1.0 minus 3 times 1.0 all squared. Great. So v of 1 is equals to minus 1 plus 6 times 1 is 6 minus 1.0 squared is 1 and 3 times 1 is 3. The velocity at time t equals 1 is negative 1 plus 6 is 5 and 5 minus 3 is 2. So the velocity is in meters per second. Now the speed of this particle is, so the speed is 2 meters per second, which is the magnitude of the velocity. Now let's find what the particle will be when the instantaneous acceleration is 0. We already have the velocity function v of t. So v of t is negative 1 plus 6t minus 3t squared. The change in velocity of a particle with respect to time is called the acceleration. So when the particle changes velocity with respect to time, it attains what we call acceleration. So the derivative of the velocity function, which is v prime of t, is equal to the derivative of negative 1 is 0, the derivative of 6t is 6, and the derivative of minus 3t squared is minus 6t. This is the acceleration of the particle a of t. When is this acceleration equal to 0? So if a of t equal to 0, it means 6 minus 6t equal to 0. In this case, 6t is equals to 6 and t is equal to 1. So at time t equals to 1, the acceleration is 0, meaning the particle is not accelerating at a particular time. So let's find what the particle will be. We take the position function x of t is equals to 7 minus t plus 3t squared minus t cubed, and then we substitute t equals to 1. So x of 1 is equals to 7 minus 1 plus 3 times 1 squared minus 1 cubed. So x of 1 is equals to 7 minus 1, that's 6. So it's 6 plus 1 square is 1. 1 times 3 is 3 minus 1. This will be equal to 6 plus 2, and 6 plus 2 is 8 meters. So when the instantaneous acceleration is 0, the particle is 8 meters away from its starting point on the x-axis. Thank you very much for watching this video, and see you in our next video.